Professor Belfrost's science class is back.
Hi, welcome back to this channel. And today we'll again discuss another concepts related to science. So here's the science tutorial for you today. Are you ready? Let's continue playing this video. Okay, welcome back to our channel, and today we will again discuss another set of exam problems that I have compiled. Okay, so yeah, as usual, we have one mathematics question, one physics problem, and also one chemistry problem. We start with mathematics. Okay, so yeah, this is the question. So let X be the set consisting of the first two 2018, okay, which is 2018. I mean 2018 in terms of the arithmetic progression 1, 6, 11, blah blah blah, and Y be the set consisting of the first 2018 in terms of arithmetic progression 9, 16, 23, blah blah blah. Then yeah, this is ellipsis actually. Then the number of elements in the set X union Y is okay. So we are given sequences up to 2080 terms. Okay. So for one, it is 6, it's 11, it is 16, up to this. How to find this? Yeah, this is just basic arithmetic, right? A plus n minus 2, which is 2000. It's hard to write in my laptop. Times b. B is the difference, which is 5 here. Okay, if you calculate this, I'm quite sure that you'll get the one that, okay, which is 10,086. And also for this set, okay, this arithmetic set, you also end up with 4128. Okay, so the first one is that we need to find out the common terms of these two sets. Okay, and yeah, actually you need to find out more numbers before you can get this kind of set. Actually this is wrong. Okay, this one I picked from the the textbook. It's wrong. This is the set actually. Okay, 16, 51, 86, blah blah blah, and you can see the difference between one term and the other term. It is 35. Okay, and the Tn must be less than or equals 10,086. Okay, because why? If it is greater than 10,086, then you will, okay, share no common terms, because you need to have both terms become common. It means that it must be the, yeah, the member of both set, which is from this 16. So the number must be greater than 6, greater or equal than 16, equal to 16, and less than or equals 10,086. Okay, so let's see how many common terms are in this set. Okay, and after you're doing some calculation, you get the thing like this, and you round it down. Okay, you round it down, and you get 288. So there are 288. Okay, 288 common terms between 16 to 10,086. So why the total number of element, and yeah, when we reduce the duplicate term, which is 2018 plus 2018 minus 288, which is 3,784. Okay, that's the answer. Now the second problem is related to physics. So in a radioactive decay chain, the 232 thorium nucleus decays to 212 plumbum, okay, nucleus, and let n alpha and beta, the number of alpha and beta minus particles, respectively emitted in the decay process. Which of the following statements are true? Okay, first we need to find number of alpha particle. We need to know that alpha particle have the charge of positive 4, because this is very important. And then we need to find how much the difference between these two number atom. Okay, so we have 232 minus 212. It is 20 divided by 4. Okay, because it is the number of charge of each alpha particle. So we have 5 alpha particle here. So you can complete the equation till here. but we're still missing one beta term. Okay, how to find how much beta minus particle involved? Okay, you can done it by using this. Okay, it involves the number of mass. Okay, so 90 equals 82 plus 5 times 2 plus n. Okay, and it is still not found until this step, minus 1, right? Okay, beta have minus 1 charge. So n equals 2. So we put this, and it means that the correct answer are A and C. Number 3, I mean it's related, is the third problem in this video, a chemistry problem. The sum of the number of lone pairs of electrons on each central atom in the following species. Okay, we have yeah, tellurium, yeah, T3 is tellurium, Br6. Okay, we have Brf2, okay, positive, SnF3, and Xc, okay, xenon, F3 minus, with this atomic number information. So yeah, the first thing after you get these atomic numbers is to find the number of valence electrons, because this is very important. Okay, we know the lone pairs are on the central atom by first identifying how much valence electron are the, yes, on the central atom. Now let's see which is the central atom for this ion. The central atom for this anion is tellurium. Okay, tellurium has 6, okay, 6, but this plus 2 because it gained 2 electron, so it has 8 electron, and it is shared to 6 bromine. Okay, 6 bromine, which require 1 electron each, right? So 8 minus 6, it is 2, right? 2 electron, it means that 1 pair. How about Brf2 plus? Okay, Br, it has 7 electron, but it is plus. It donor 1 electron to the other, to, yeah, its neighbor. So it left with 6, right? 6 electron. So 6 electron, and fluorine it's accept, okay, except 2, 1. I mean one electron. So there are 2 fluorine. It means that 2 atom, 2 electron. I mean, so 6 minus 2. This is 4. 4 divided by 2, because it means pair. 4 by 2 is 2, and then SnF3. Okay, which are the central, which is N here. Okay, so N has 5. 3 has been set to fluorine. 2 has been set to this sulfur. So actually, it has no lone pair. How about xenon F3? Okay, xenon have 8, but it has give it to 3. Actually, this is 8, but it gains 1 electron, so 9. 9 share 3, it is 6. So 3 pair of lone, 3 lone pairs on the central atom, which is the xenon. So 1 plus 2 plus 0 plus 3, there are total of 6. Okay, before I end this video, I will share a little quote for you. So a Japanese prophet once said, fall 7 times, stand up 8. It means that you should never give up. Thank you. That's the end of the video for today. Thanks for watching, thanks for following so far. And here's what you need to do. Please subscribe, give a thumbs up, comment, and share this video to your friend. And also, don't forget to check our website at https://science with exploits.unaux.com, and I'll be back on every Tuesday, so keep watching and be thoughtful. Goodbye, see you.